Now I'm going to get back the original data frame, myDF, so that I can illustrate a different technique. So that's all this code is doing, is getting back to myDF that I had before I did different things to it. A technique that people sometimes use is ordinal encoding. Instead of encoding the cap surface column via 4 binary columns like we did with one-hot encoding, we could have replaced the values with numbers. We could have just said, okay, let's make S be 0, let's make Y be 1, F be 2, and G be 3. This is a function with a finite domain of S, Y, F, and G, and there's no easy formula for it. And you may remember, or may not, but earlier in the class we talked about how you can use dictionaries for functions like this in Python. There is a map command which will allow you to apply a function to a column in a data frame. And Python will recognize that when I do this dictionary, which represents this table, I can apply it. So after I create this CF dict dictionary, CF stands for cap feature, cap surface feature. After I create this dictionary and do map, I now see that I am going to create an encoded df. And when I do encoded df.head, you can see how this looks. I'm going to include a few more rows than I ordinarily would. So I've replaced every S with a 0, every Y with a 1. And when this goes deeper and there are more observations, or when I see different values for the feature, I will also see, for instance, that F got replaced with 2, just like I defined here in my dictionary. This technique is called ordinal encoding. You're replacing the possible values with a set of integers, usually either 0 through n-1 or 1 through n. After you do this ordinal encoding, you can drop the original column and just keep the information that you got from it in the form of the numbers.